Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad bin ZULKIFLE from UITM SHAH. In this project, the layout plan of proposed development phase 1 is given, and the project comprises residential house, surau and kindergarten with total water demand of value Q. The supply line from reservoir also caters for the area of phase 2, which is scheduled to be developed in later stage. The water demand for phase 2 was assumed to be equal value to 1.5 Q of water demand from phase 1. The objective of this project is to determine the design flow, to propose a water supply, reservoir and pipe network, and analyze the residual head for the proposed pipe size. This is the proposed development for phase 1, water reticulation layout plan. From the layout plan shows before, I divided this presentation into 3 major topics, which is the concept of design, design process, and tank design. Concept of design. This is the concept of my pipe network design that consists of several interconnected pipes with multiple junction and draw-offs. From these interconnected pipes, it will make it as 5 loops for phase 1 development. The proposed properties of pipe. I've choose high density polyethylene HDPE material as pipe due to its high stiffness, strength, toughness, moisture and resistant to chemical and gases. It also easy to processing and good for performing. Generally, I assume all diameter of pipe is 200 mm and the roughness coefficient is 130. Design process. First at all is the water demand. This is how I made the calculation of the demand. Based on the authorities, every single story terrace need about 1,360 liter water per day. As the example for loop 1, get 72 units of single story, then multiply it with 1,360 to get the water demand for loop 1. For my design, I get the total of water demand is 279,740 liter of water per day for 5 loops. Selection of design scenarios. At this point, I need to make of calculation of peak flow and fire flow. For peak flow, 2.5 need to multiply with total water demand, and I got almost 700,000 liters of water per day. Next, fire flow, the total water demand need to plus with the fire risk, and I get about more than 5 million liter of water per day. From both of the results, take the dominant value as the flow rate design. By the value of flow rate for phase 1, we can get the total water need to supply including for phase 2. For fire hydrant, I assume the flow rate of the farthest nodes from the reservoir. Head balance method. After propose the diameter and length of the pipe, we can find the loss coefficient using Hazen-Williams equation. After that, for the next column, I use head loss equation. This is the equation to find the correction flow rate, and this is for the adjoining pipe. For example of joining pipe is both in the yellow label in the iteration table for loop 5 and 4. And to get the delta Q, we can use the Hardy-Cross method by this equation. Residual head. From the value H0 minus head loss by cumulative, we get the value of H. Next, the value of top water level is by summation value of platform level, building height and suction tank height. From all the values stated, we can get the residual head using this equation, but need to make sure the value must greater than 7.5 as the requirement. This is the final flow rate design with the location of the fire hydrant as the farthest point from the reservoir. Water tank reservoir design. The total daily demand for both phases is about 13 million litres per day. However, for service tank demand is only about 8.5 million litres per day. From that value, we need of 3848.45 meters square of available land area. That can be proved by these physical properties of the tank, designed with structural height, tank depth, and tank diameter that give the value of 27.43 meters square of tank area that can accommodate up to 8,765.04 meters cube of water. Moreover, this is the calculation and value of hydraulic gradient line. For additional, my water tank is designed to build as a concrete water tank. I choose concrete because it was available in every size and capacities. It also long-lasting with maximum strength due to reinforced steel in the concrete. More than that, it also excellent to insult properties to keeping the water cool. Even if there is some disadvantages such as cracks and leaks, there will also comes with the solution, which is waterproofing seal for inner surface of the concrete tank and polyurethane fuel injection grouting to immediately stop the water from leak if there are some. That's all for my presentation. Thank you for your attention and time.